Alright, we're given that one side of a triangle is 5 centimeters long. And then we're going to choose two real numbers at random between 0 and 10. And the question asks, what's the probability that the two numbers chosen could be used to form the other two sides of a triangle? Alright, so let me just draw. So we got one side that's 5. And then we're going to choose another one. Let's call that x, and we'll choose another one. We'll call that y. And what's the probability that we could make a triangle out of those? All right. So you can see not every number we choose could make a triangle. Like if we have one side as 5, and let's say we choose 1, and let's say we choose 2, you can see that we can spin these legs around as much as we want, and they're never going to meet up and make a triangle. Okay. So, so not all not all of our choices will make a triangle. We want just the ones that are going to make a triangle. And there's something called the triangle inequality theorem. Okay, triangle inequality theorem. Okay, and that just says that the sum of the lengths of any two sides of a triangle has to be greater than the remaining side. Okay, because otherwise you get this case where you have these short little stubby legs that never meet up. All right, as much as we swing them around, they're never going to meet up. So at minimum, they have to be greater than this side. So if this is 5, for example, then the sum of these two you have to add up to 5. So one, in the boundary case, we'd have, if we had 2 and 3, that's not going to make a triangle. But if we were just a little bit longer, if we had a side that's 5 units long, and we had 2.1 and 3, we would make a very shallow triangle, but we could make a triangle. Okay. So that's the triangle inequality theorem. Okay, it just says that the sum of the lengths of any two sides has to be greater than the length of the remaining side. The other thing about this problem that's a little different than many other probability problems that you'll see is that we're dealing with real numbers. Okay, we're not dealing with integers, so we can't count the number of possibilities of numbers between 0 and 10, right? Because we're not dealing with integers or natural numbers or whole numbers. We're dealing with real numbers, so I can choose pi if I want to. I can choose e if I want to, which is, and I could choose 2.1469834 if I want to. So there's essentially an infinite number of numbers between 0 and 10 if you're considering all real numbers. So we can't treat this like a counting problem over a counting problem. What we need to do is think of it in terms of geometry. And we've got two variables. We have two real numbers. So what I'm going to do is I'm going to show one of the sides on one axis, and so essentially we have two number lines here. Okay, and we're going to choose something between, let's call this 10, and let's call this 10. Okay, we're going to choose something between 0 and 10 for both of these two numbers. So the total possible pairs of numbers that we can choose are going to be in this region, this square, this 10 by 10 square. Okay, so rather than our probability is the desired outcomes over the possible outcomes. But in this case, it's going to be areas. We're at least because we have two variables. We're going to measure the numerator and denominator in terms of area instead of a counting problem. Okay, so the total possible outcomes is defined by the area of this 10 by 10 square, because this shows us all the numbers that we could possibly choose. I could choose here. Maybe that's 8 and 6. This or something like that. So all of the points that we could choose are going to be within this area, and the area is 100 square units. All right. So now we just have to figure out what area within this is going to give us a triangle, and which pairs of numbers are going to give us a triangle. And one way to do that is to look at the boundaries, okay? So, and the boundaries are going to be defined by the cases where you get exactly, you have two legs and another side, and they're exactly equal to each other. So it's basically, it's not a triangle, but anything bigger than that would be a triangle. Anything less won't make a triangle. So that's right at the boundary. Okay. So let's break this up into cases. All right. So let's look at the first case. Let's assume in the first case that the long side of the triangle is the 5 centimeters. Okay. So in this case, x plus y has to be greater than 5 by the triangle inequality theorem. Or I could rearrange that as y is greater than negative x plus 5. And we could show that on here. This is essentially in, if you've had any algebra, this is in point slope form. So the y-intercept is going to be 5, and it's going to have a slope of negative 1. So it's going to come down here. Let's say this is 5, and it's going to look like this. So the region where x plus 5 is greater than, x plus y is greater than 5 is going to be on this side of the line. I'm not going to shape the whole thing, but yeah, it's because I've got more inequalities here. Anything down in this region is not going to make a triangle, because if you had, say, 1 and 1 with a 5 with the other side being 5, no, can't make a triangle. Okay. All right, let's look at another case. Let's assume in the next case that the long side is x. Okay. So what does that mean? That means that 5 plus y has to be greater than x. Okay. Now let's put this in point slope form, just so it'll be easier to plot. So this is y is greater than x minus 5. Okay. So I can plot that line. Okay, it's going to intercept down here somewhere, negative 5. And you can see then when x is equal to 5, y is equal to 0. So it's going to pass through this point, and it's going to come up here to 5. Okay. So that's what that line's going to look like. So that's the case where the long side is x. Alright. So there's one more side. So let's take case 3 to be the case where the long side is y. Okay, so in this case, x plus 5 has to be greater than y. Okay, and so point slope form, we're kind of already in point slope form. We could also write this as y is less than x plus 5, right? Just turn it around. And so that is going to have an intercept of 5, and it's going to go up with a slope of 1. So it's going to look sort of like it's going to come up to here. Okay? So that's our boundary. Those are our boundaries. So this is where this boundary is where the long side is 5. Here's where the long side is x, and here's where the long side is y. All right? So within this region, bounded by the triangle inequality theorem and the conditions where we're going to choose numbers between 1 and 10, essentially anything in this region is going to make a triangle. Okay? Does that make sense? So any point we choose within this region bounded by these lines is going to form a triangle. So let's try and figure out what the area of that region is. And probably the easiest thing would just be to take the whole square and subtract out these corners. So there's 3 corners, and the sides are, 5 and 5 for each one. So we can end up taking the total of 100 and subtracting out 3 of these 1/2 5 times 5 corners, okay? because all of these are going to be just basically half a square with a length 5. Alright, so if we do that, so that's essentially 100 minus 75 over 2. So I can take 200 over 2 minus 75 over 2, and that gives me 125 over 2. And that's the area of this region, okay? The region where we're going to get triangles. And these little corners are the places where we don't get triangles. Alright, so to get the probability, we just need to compare the areas. So this is our desired, these are our desired outcomes, where a triangle is formed. Our total possible outcomes, the area of total possible outcomes is 100. So if I take 125, here I'll write the probability is equal to 125 over 2 divided by 100. And let's simplify that down a bit. I can essentially take 25 out of each one of these. This is 5 times 25. This is 4 times 25. So, and then I've got this over 2 thing. I can put that on the bottom. So I end up with 5/8. Okay? So the probability that we choose two numbers at random between 0 and 10, where they're real numbers, any real numbers will do. If we choose any real numbers between 0 and 10, the probability that they form a triangle with one side that is 5 is going to be 5/8.